Hello everyone, in this video we're going to learn how to graph linear inequalities, and then we will talk about how to solve them. So the first thing I want to talk about is how to graph an inequality on a number line. So the first example is x is greater than 4. So the first thing that we want to do is when we graph an inequality is we want to make sure that we have a number line ready. So we will go ahead and do that. And then just use 0 as a reference point, and then now plot the number that is given in the inequality on the number line. 4 is going to be to the right of 0, and you don't necessarily need a specific scale. As long as 4 is to the right of 0, that should suffice. And then now we want to use, now when you graph linear inequalities, you can use circles or parentheses or brackets. Okay, so what we got to remember is that if you have inequalities such as greater than or less than, then what we're going to do is we're going to use an open circle. Okay, and basically it looks just like this. And if you have inequalities that have greater than or equal to, or less than or equal to, we would use a closed circle. And that means we shade it in, just like that. Okay? And keep in mind, you can also use parentheses if you have an open circle, or you can use brackets. Okay, so in order to do this one, okay, if you want to use the circle, then greater than in the inequality, okay, greater than is going to be associated with a open circle. Okay, so we would put an open circle where 4 is, and then everything greater than 4 would be shaded to the right. Put the arrow, and then that's in the positive infinity direction. Put the infinity signs to indicate the direction is going to the right forever and ever and ever. Okay? An alternative way you can graph this is you can, you would put 4 on the number line, and instead of using an open circle, you can use a parenthesis, but the parenthesis would be faced to the right because that's where the greater than is, right? Greater than is shaded to the right, right? X is greater than 4, so greater than is to the right, and then you put the infinity. So it's almost the same graph except you're using a parenthesis. Either one of these would be okay. Okay? And if you were to write this in interval notation, okay, if you'd like the interval notation for this, then what you need to do is you look at the graph and you say, okay, we're starting off at 4. So the 4 is going to be first, and then comma, infinity. And then remember, we have a parenthesis around the 4 because the inequality is greater than, and greater than we use parenthesis, and then we always put parentheses around infinities. Okay? So as a little footnote, we always use parentheses around negative infinity or positive infinity. Okay? And that's really all there is to it. Okay? So we'll practice another one on the next slide. Okay? So if you have x is less than or equal to negative 3, then again you would use your number line. 0 is a reference point. Negative 3 now is going to be to the left of 0. And then remember, less than or equal to is associated with a closed circle. And then less than would be to the left. Put the arrow and then indicate that's going in the negative infinity direction. If you want the interval notation, then it would look like this. Negative infinity, comma, -3. Again, we always use parentheses around infinities, and then since the -3 has a closed circle, that's associated with a bracket. And that would be the interval notation for that. Okay? Now, the next example I want to talk about is a compound inequality. What if you're given this? Okay, this is what we call a compound inequality, meaning we have more than one inequality. Here we have two. Okay, so the very first inequality we have is actually just like this. Okay, x is less than and equal to 3. The other inequality that we have is this one. And this one is actually written backwards. Okay, so it's actually x is greater than -2. It's written backwards because that's the direction we're reading it. We want to start with the variable, followed by the inequality sign, followed by the numerical. So if you want to rewrite it so that you can read it from left to right, then you would switch the location of the variable and the number, just like that, and then reverse the inequality sign. It has to be reversed, okay? And now you have an inequality where you can actually read it from left to right. Okay, so x is greater than -2, okay, is what this really is saying. So if you're confused and if you're having a difficult time reading it backwards, just rewrite it like I showed you by reversing the variable and the number and switching the inequality sign. And then you'll be able to read it without any trouble from left to right. So we have two inequalities here, okay? So then we're going to have to graph those together on one number line. So use that number line, and then we're going to put -2 to the left of 0, and then we're going to put +3 to the right of 0. And then now we just need to put the appropriate circles. Anything, let's see, x is greater than -2. So greater than would be an open circle for the -2. And then the 3, x is less than and equal to 3, that's associated with a closed circle. And then anything less than and equal to 3 is going to be to the left. And then anything, you read the other inequality, x is greater than -2, then you shade everything to the right, and you notice that it's going to overlap. And when they overlap, that is called an and, or it's also known as an intersection. Okay, that would be the more mathematical term. And when there's an intersection, we call that and. So if you were to write these as separate inequalities, you would write x is greater than -2 and x is less than and equal to 3. Okay, or you could write it as all together as the example was given, but we can separate it into two. But remember, when you graph them, they're going to overlap. So we need to put the word and in there. Okay, but this is how you would do it on a number line. I mean, this is the answer right here. Okay, all right. So now let's do another example. What if you're given this situation? X is greater than 5 or x is less than -7. What we want to do is we want to go ahead and put our number line in. Okay. And now we go ahead and plot the numbers. we're going to put 5 to the right of 0, and then -7 is going to be to the left of 0. And then you notice that both inequalities have, see, this is greater than 5 and that one's less than -7. So those inequality signs will both be equated with open circles. And anything greater than 5 is going to be to the right, to positive infinity. Anything less than -7 would be to the left, and that's going in the negative infinity direction. Here we have a space in the middle. You notice that? We have a space in the middle, or a gap, or a break in the graph, where there's no graph. So what we're going to do is, if you want to do the interval notation for this one, then you would start always from the left side, so negative infinity, parenthesis, because we always put parentheses around infinities, comma, -7, and open a circle is associated with a parenthesis. And then to indicate that there's a gap or a space, we want to use the union. And then now we want to use the parenthesis because we have an open circle, and then that's around the 5, comma, positive infinity, close parenthesis. Okay? So here, when you have an or, then the graphs are going to split in opposite directions, and then there'll be a gap in between those graphs. Okay? So that is definitely not an overlap. Okay? All right. So, what if I gave you the interval notation and I want you to write the graph that represents that interval notation? Well, again, draw a number line, and we're going to plot both numbers, okay? 0, and then we're going to plot 3, which is to the right. So we'll put this in black. And 0, you notice that it has the bracket, so that's associated with a closed circle. So we're going to put a closed circle where the 0 is, and then the parenthesis around the 3 is associated with an open circle. So we're going to put an open circle where the 3 is, and then you notice that the direction of the bracket is facing this way. So that's where the graph is going to be. We're going to graph it right in between here. And you notice the parenthesis is facing to the left, so that means we're going to shade everything to the left. So again, that clearly there's an overlap here. And then that would be the graph of that, for that interval notation. Okay? Let's do another one. Okay? So we draw our number line, and then use 0 as a reference point, and now -3 is going to be to the left of 0, and 5 is going to be to the right of 0. Okay, you notice the parenthesis is associated with an open circle, so that's what we're going to put around for the 3. And the bracket is associated with a closed circle, so a closed circle needs to go where the 5 is. And now you notice that the bracket is facing left, so that's the direction that we're going to shade. And then the parenthesis is facing to the right, so we shade back to the right. So again, that's another overlap. Okay? And that's all there is to it. Okay? All right. So let's do... Okay, what if you're given this? Okay, let's say you're given a graph. Okay, and we have -0.05. And then here we have 1, that's an open circle. And let's say I gave you this graph and I want you to find the interval notation. Okay, So the first thing I want you to do is what is the interval notation? And the other question I want you to think about is what are the inequalities what are the inequalities based on the graph that's given, right? So the first thing we want to do is, it might help to identify what the interval notation is, and that way, you don't have to, but I like to show it anyway, and then from there we'll do the graph, okay? So what if they were to ask for the interval notation? Well, again, you start with the leftmost quantity, which is negative infinity. Okay, we put parentheses around those, comma, negative 0.05, and then that's a closed circle. A closed circle has a bracket. You notice that there's a space or a gap here. So then we're going to put a union to indicate that, and then now the graph picks up at 1, but you notice there's an open circle, so that has to be a parenthesis, comma, positive infinity, and then we close the infinity with parentheses. That's what the interval notation will look like. It's an OR. Okay? Because they're splitting in separate directions, okay? So now, what is the inequality that represents the left interval notation and the right interval notation, right? So we'll start with the first one, negative infinity, comma, negative 0.05. So again, we're going to use x as our variable. So, and you notice that the direction of the graph, if you look here, okay, the direction of the graph is going here, going towards the left, right? So we start at negative 0.05, and if you're going towards the left of negative 0.05, which is what that graph is doing, then left has to be less than and equal to. Okay? Has to be less than and equal to. And we know that because a closed circle is associated with less than or equal to. Okay? Left is going to indicate that inequality sign. And just use x or any other variable you would like. Okay? And then the other, since it's a union, we're going to use OR. Okay? And that's because, okay, it's a union. Okay, does that make sense? If there's a gap, then we put the U in there, and that indicates that the graphs are splitting. So there's a space in between them, so we want to use the word OR. All right, and then for the other inequality on the right side here, we're starting with 1, and now we want to use x as our variable. Now to the right is greater than, but however it's an open circle, so it's just going to be greater than 1. Not equal to, because it's not shaded. All right, so you got to look at the circles, and that indicates what kind of inequality sign you're going to use. And that's all there is to it, okay? So the answer for that, okay, will in fact be this. If you want the inequalities. If you want the interval notation, then yeah, that'll be what I gave you for question number 1. Okay? All right. So Now we're going to transition into something else, okay? And we're going to translate a few statements into inequalities, okay? So we'll go to the next slide. Okay, and before we do that, there are some common words. Actually, let me before I present the example, there are some common words that express inequalities. All right, and the first one is greater than. Okay, and that's simply this. And common words that are used for greater than would be more than. You can use the word exceeding, above. Okay. So those are the ones you're going to see quite often. Okay, so I'm only going to list a few of them for each category. Okay, just to give you an idea of some of the common words that are used that you're going to see quite frequently. Okay, and you're going to see some are very similar to the others. Okay. The other one is greater than, or equal to. Greater than or equal to is basically like this, right? And at least is a word we use. We say no fewer than. We can say minimum. And we can say top. We can say no less than. Okay? Yeah, okay, let me just rewrite this. I don't like the way it came out. Yeah, minimum. I want to make sure you can read my writing here. There you go, that's better. No less than. Sometimes the pen slips and it makes it difficult to write. But, so those are the common words that are used for greater than or equal to. Okay? The other expression is less than. And that's simply this one. Okay, so less than, we can use the following words. Fewer than is common. Below or under. Okay, let me write this a little bit better here. Sorry about that. Okay. So those are some common ones. And then the last one I want to talk about is less than or equal to. Which is that symbol. All right. And some of the common phrases that are associated with that. Another one is no more than. Not above. Does not exceed. Okay. At least. And bottom. Okay, so those are the common words to look out for. There's probably going to be more, but these are generally a few of them that you're going to see. Okay, so use this table to help you, and it'll generally give you most of what you're looking for in general terms. Okay, so if we go to the next slide, okay, and then now I can present an example. So the first example that I would say is, let's say we had Tony had no more than 2 traffic offenses. And I just want you to translate that statement into an inequality, okay? Again, you can choose any variable you want. You can use T for Tony, you can use X, you can use whatever you want, doesn't really matter, okay? So you can say X, and then now the key word is no more than. That's what you want to look for, right? No more than. So if you go back to the previous slide, which I'm going to do right now, and we look at no more than, and here we have it right here, okay? No more than, which is right there, okay? And then now we use that, no more than, and you notice we're using less than or equal to, okay? So we're going to use less than and equal to, and then of course 2 is the number we're using. Okay, and that's all you do. Okay, that's all you do for that one, and that's your answer. All right, so another one you can say, this is a good one right here. Okay. Okay, or okay, so this is just an example. To enter a theater, you must be at least 18 years old or under 12 months old. Okay, so how would you express this as an inequality? Well, you actually have two quantities here. You have at least, right? At least 18 years. And then the other equality is under 12. So under is the word, and then 12 months. Okay? Which you can equate with 1 year, actually. And that way it matches the units for the other age as well, 18 years. Okay? Because if you put 12 in the inequality, people could mistake that for 12 years. All right? So let's write the first inequality, at least 18 years. Okay, so we'll write this one, and we'll use x as our variable. Now, at least, again, if you go back, at least is right here, and therefore we're going to use that inequality sign, greater than or equal to. Okay, greater than or equal to. And what is the number? It's going to be 18. And then in order to do this one, we have x, and then we look at it, the word under, go back. Under is right here, so we're going to use that inequality sign, less than. So we're going to put less than, and then again, instead of putting 12 months, we're just going to use 1. That way the units match, right? And those are your two inequalities right there. Okay? So here's one of them, and here's the other. Okay? And that's it. So you have to use that little chart that I gave you to help you with the words to choose. And that way you can associate that expression with the appropriate inequality sign. Okay. So now that you have a good solid foundation on interval notation, graphing inequalities on a number line, translating expressions into inequalities, now we'll spend some time going over some basic inequalities, okay? So now we're going to solve. Inequalities. Okay, so I believe the previous example of the slide was 8, so we'll be at number 9. Okay, again, we're going to solve some basic inequalities. So we'll start off with this one. And solving them is just like solving equations, right? You get the variable on one side and the numericals on the other. So the only thing we have to do here is we're going to add 3 to both sides. And then we're just left with x is less than or equal to 5. Okay? And that would be your solution, okay? So this here is called the solution. Okay? And again, if you want to graph it, 5 is there. Less than or equal to is a closed circle. And then we shade everything to the left because less than is to the left. And that's to negative infinity. If you want and that's called the graph. Okay, this is the graph. If you want to do the interval notation, then you go from left to right. Start with negative infinity, parenthesis, comma, 5. Closed circle is associated with a bracket. So by now we should be pretty fluent in graphing them and converting them to interval notation based on all the information I gave you. Okay? All right. So let's do one where we actually have to what if you're given this? Okay? What if you're given a compound inequality? How do you solve a compound inequality? When you have just a regular inequality, you get x on one side, the numbers on the other. You follow the same algebraic rules as solving equations. Okay, nothing's really going to change, right? Compound inequalities, the x variable is going to be in the middle. Okay, x plus 3. And what we want to do is we want to isolate that variable in the middle by getting rid of that whatever is to the right of that, which is going to be positive 3. So the opposite of positive 3 is negative 3. We want that term to cancel out in the middle. However, we do that on both sides of the inequality sign, and that's to the right, and that is to the left. okay? Because you have two inequality signs. One to the on the left side and one on the right side. So you got to subtract it 3 times. One's in the middle, one's on the left, and one's on the right. The term in the middle should cancel, and then you're just left with x. And then, of course, you just bring down both inequality signs, and they'll perform the operations on the left and right of it. -1 minus 3 is -4. 6 minus 3 is 3. Okay? And now you have two inequalities. And now remember what I said. This one is written from left to right. This one is backwards, which is written from right to left. So if you want to rearrange it so that you can read it from left to right, then you do this. Switch both the variable and the number, and then reverse the inequality sign, and now you can read it from left to right. And if you want to graph it, now you plot the numbers. -4 is to the left, 3 is to the right. So greater than -4, that's going to be a closed circle. Greater than is going to be shaded to the right. Less than is an open circle, and we shade back to the left. So that's an overlap right there. If you want to do the interval notation, again, you start with the leftmost quantity, -4, 3. The closed circle above the -4 is associated with a bracket, and then the open circle above the 3 is associated with a parenthesis. And there you have it. That's your interval notation. Okay? Okay, let's do another example. Let's say you had this one. Okay. So when you have inequalities with fractions, again, it's probably better if you find the common denominator. And we do that if you take both denominators 2 and 4, and you do multiples. Well, if you start with the smaller number, the smaller denominator, and do multiples of that, 2, 4, you notice that 4 appears in both rows first. So that's considered the LCD. Okay? So what we're going to do is we're going to take that LCD and we're going to multiply it by both sides of the equation. Okay? And now we want to cross cancel the 4 and the 2. And you notice that 2 cancels, 4 divided by 2 is 2. And then we do 2 times 1, which is just 2. Notice the 4's both cancel, and you're left with 3. So that's going to be 3 times x minus 4. And now we can use the distributive property, okay, like we've learned, right? Because we need to get rid of parentheses. So 2 times x is 2x, 2 times 2 is 4. And then we do the same over here. 3 times x, and then 3 times -4. Well, 3 times x is 3x, and 3 times 4 is 12. And now we need to get all the x's on the left and all the numericals on the right. Now you can get the x variable on the right side if you want. It doesn't really matter. I just like to get it on the left so I can read it from left to right. Okay, so for simplicity reasons, I'm just going to subtract 3x here. And that way I'm just left with 2x minus 3x is minus x. Plus 4 is greater than or equal to minus 12. And then now I'm going to move the 4 over to the right side by subtracting it. Always do its opposite. So then you have negative x greater than or equal to negative 16. Okay, and then now we divide both sides by a negative 1 because I'm not interested in negative x. I want to know what x is. So I'm going to divide those negatives out, and then you're just left with x. And then now we got to flip the inequality sign because you're changing the signs on both sides, right? A negative becomes a positive. A negative 16 divided by a negative 1 is a positive 16, and both sides became positive now, so we've got to reverse the inequality sign. So this would be the answer. Okay, and then graphing it should be super easy. You're going to put 16 to the right of 0. Less than or equal to is associated with a closed circle, and then we're going to shade everything to the left to negative infinity. Interval notation is negative infinity, comma, 16. You always go from left to right. Always put parentheses around infinities, and then a closed circle above the 16 is associated with a bracket. Okay? And that's it for that. Okay? All right. So I have a couple more examples to show you. Okay, absolute value equations. They're actually very simple. When we talk about absolute value, remember we said that the absolute value, okay, is the distance from 0. Okay, so distance is always measured as positive, right? So here, x can be 7, and x can be negative 7. And the reason why I say that is because if you want to check, okay, and if you take the absolute value of 7 and plug it into this equation and tell me if it equals 7. What is the absolute value of 7? It's 7. Same goes over here. What is the absolute value of negative 7? It's also 7. So therefore, my solution has to be both of these. So you've got to think, what do I need to plug in for x so that I get, what do I need to plug in for x, take the absolute value of that to get 7? Well, 7 and negative 7, if I take the absolute value of both of those, I still get a positive 7. Okay? So, that's what the answers are. Okay? If you have something like this, and I say to you, solve that equation, well, you have to write two separate equations, right? So you're going to have to write 5 minus x equals 6, and 5 minus x equals, it's negative, it's opposite. Because when you plug in 6 and negative 6, you know, it's going to turn into a positive. So write both equations without the absolute value on the left. Set one equal to its positive value and its negative value. In this case, 6 is going to be the number of the original equation, right? So we want to equal positive 6. One equation equals negative 6. And then solve both of them for x, which should be easy. Okay. So then you're just left with minus x equals 6 minus 5 is 1. Again, we should be dividing both sides by negative 1, or just flip the sign, so you get x equals minus 1. All right, same thing here. Going to get minus x equals minus 11, right? Flip both sides, and you should get x equals 11. or divide both sides by -1, and then both sides will turn into a positive. Okay, so solving absolute equations are pretty easy. One's going to be positive, one's going to be negative, and solve both of them. Okay. One last thing here. Okay. What if you're given an absolute value inequality sign? Well, you kind of do the same thing what we just did with the equations. You're going to create two separate inequality two separate inequalities, and then you're going to solve both of them. One's going to be positive, one's going to be negative, right? But there's one thing you're going to do with the negative one. All right, so watch carefully. So rewrite it, and then one is going to be +3. The other one's going to be -3, but then we reverse the inequality sign because of that -3. That's the only thing you got to do differently, and then you would just solve both of them for x. Okay, so we have to flip that inequality sign for the negative value. And then we just solve both of them for x. So again, I'm going to subtract 1. And I get 2x is less than 3 minus 1 is 2. Divide both sides by 2. Notice I'm not flipping the inequality because I'm dividing by a positive value. So that's another thing to keep it careful with. If you're dividing by a negative integer, then you flip the inequality sign. But if you're just dividing by a positive integer, you keep it the same. All right, let's follow the same procedure here. Okay. And then now, again, we're dividing by a positive value, so we keep the inequality the same. -4 divided by 2 is -2. And then there you have it. Those are my two solutions, okay? Okay, so I hope that this video was very helpful, and it gave you more than enough information to handle basic inequalities, graphing them and putting them in interval notation, translating statements into inequalities, and solving linear inequalities, including absolute value equations and absolute value inequalities. Thank you.